Welcome to the second lesson of the Knowledge Representation on the Web course. Today we will be looking at the web ontology language OWL, which mostly represents an extension of the RDF and RDFS language that we saw in the previous class. Just to give you an outline of the course, this class is mostly divided in 4 parts. We will be briefly discussing the differences between RDF, RDFS, and OWL, and then we will dive into OWL specifications like OWL properties and restrictions, class actions, and necessary and sufficient conditions. So starting with a bit of motivation of why do we need OWL? If you recall the RDFS schema we discussed in the previous class, it turns out that the semantics that we can express with RDFS is rather limited. So we looked at terms that describe classes like RDFS class or subclass of. We look at domain and range and subproperty to describe properties. We didn't discuss them in depth, but RDFS allows to include special classes like RDFS resource, literals, data type. So it depends whether you're specifying a URI or literal values. There's also some less frequent features, frequent terms that you will see less often, like RDFS member or container, or properties like comment and labels, which you might see a bit more often. The question we ask is whether these restricted symbols are enough for the type of semantics we humans use as to communicate in their daily lives. Imagine having to define classes in terms of members that have a certain properties. So for example, the class food teacher is made of all the teachers who teach a full course. Expressing these in RDFS is actually not possible. Imagine also properties that in the real world have certain cardinalities or they include negations. So a person can only be married to one other person maximum. Or maybe Ilaria is not a dentist. So these are typical restrictions that properties in the real world have, and we might want to express in an ontology. Additionally, we have characteristics like transitivity or symmetry. Imagine if you want to, if you have an ontology representing the Formula 1 domain, and then you say a tire is a part of a wheel and a wheel is a part of a car, therefore a tire is part of a car. This is a transitive relationships, and you might need and want to express this information in an ontology. The same is worth for symmetry, where you want to express that if somebody is married to somebody else, Alice is married to Bob, then Bob is also married to Alice. All this is it's showing how the RDFS semantics is limited. Sometimes we might want to be able to declare that certain things in certain resources on the web are the same across different data sets, especially in these days where we have multiple instances of ourselves in imagine in social media, for example. So I have an account on LinkedIn, one on Facebook, one on Twitter, but my these URIs are still representing the same real world entities. So you might want to be able to do the same with additional resources and to point to resources across different data sets. There's a need to represent data consistently. So we need mechanisms to check consistency continuously, and all these characteristics, all these restrictions are things that you cannot handle with RDFS, but they are very important when you deal with an application based leading on the web and based on web data. So the solution to this problem is the OWL, or Web Ontology Language. The owl as an animal has actually been adopted as the official mascot of the language. And this language is an extension of the RDF and RDFS language that we saw in the previous class. You can still intend OWL as a set of keywords. We say that a set of keywords or special keywords can be called the vocabulary that allows to extensively define classes and properties. So you're still defining classes and properties and individuals the same way you were doing in RDF and RDFS, but with OWL you will be able to express more things. So one way to say this, another way of saying this is that OWL is more expressive than RDF and RDFS. OWL is built on description logic, so all the semantics that you could express with description logics can also be expressed in OWL. As we said, it extends RDF and RDFS both in syntax and in semantics, but it includes further restrictions. So it allows you to say additional things on the concepts that you create. And it is more strict in terms of separating between instances, classes, and properties. There's as we said, you need to imagine the OWL language as a language that is more expressive than the RDFS one. So if before we could express certain things in the RDFS world, we will be with OWL, we are now able to express a much larger amount of things. There have been, over the years, there have been two major versions presented. First, 3 sub-languages were defined. And these 3 languages are mostly from the least expressive to the most expressive. So OWL Lite is the least expressive, then you have OWL DL and OWL Full. They go from being less expressive to most expressive, but this also comes with a cost. So OWL Lite is easier to use, it's less expressive, and it has a limited number of restrictions. OWL DL allows to includes almost all the description logic expressiveness, but is computationally expensive. And similarly to OWL Full, which is complete, so you get a lot of freedom to represent certain things, but it's very computationally expensive. Additionally, so these are 3 sub-languages, OWL sub-languages. Additionally, in 2009 with OWL 2, some profiles were different profiles were created for instead of OWL Lite to allow additional expressiveness. The only thing you need to remember is that these different languages, sub-languages or dialects, if you want, in OWL change in expressiveness, and the one you're going to choose mostly depend on the application you're going to implement. Most of the time, OWL Lite or OWL DL is more than enough.